as I mentioned in class, most of this first quarter of calculus, we're going to be discussing rates of change. So the first rate of change I'm going to talk about is an average rate of change. And this takes us back to our middle school story problems. For example, if I want to drive, if I drive from Port Orford and leave there at 10 o'clock in the morning, and I go to Waldport, and I get there at 12:45 in the afternoon, and the distance between Port Orford and Waldport is 133 miles. If I calculate what was my average speed over that distance, that would be an average rate of change. So what I want to know is my average speed, and my average speed would be miles per hour. So how many miles did I do? I did 133 miles. And the time between 10 o'clock in the morning and 12:45 in the afternoon is 2 hours and 45 minutes, or 2.75 hours. And that would equal, or approximately equal, 48.36 repeating miles per hour. Now, what this doesn't tell me is that I was doing 48.36 miles per hour all the way from the time I left Port Orford until I got to Waldport. Because between Port Orford and Langlois, I was probably doing 55, then I slowed down to 40 in Langlois. So if we kind of look at the graph of time versus distance traveled, I start out slow in Port Orford. As soon as I get out of Port Orford, I can go up to 55 miles an hour. I get to Langlois, I slow down, then I go up to 55 miles an hour. Then I get to Bandon and slow down, then 55 miles an hour, then Coos Bay and slow down, 55 miles an hour, Reedsport and slow down, 55 miles an hour. Then I slow down because I don't like the windy curves between Reedsport and Waldport, so I do some slow stuff, and I finally end up in Waldport. So if I was actually looking at it, I may be doing 40 miles an hour here, 25 here, 15 to 20 in parts of Coos Bay, 30 miles an hour there, put the rest of these at 55, and then over the long run, it would average out to 48.36 miles per hour. So another interpretation of what this average rate of change is that if I were to draw the line that starts where I started, ends where I end, and were to draw a straight line through that average rate of change is going to be the slope of what we're going to call a secant line, of the secant line of a function. And a secant line is a line that goes through 2 points of the function. The equation that I can use for the average rate of change is the change of the dependent variable over the change in the independent variable. So average rate of change, I'm going to put ROC, is equal to the slope of the secant line, which is equal to the change in the dependent variable over the change in the independent variable. If I'm using x's and y's, the x's for my independent, y's for my dependent, that would be the change in y over the change in x, which would be y2 minus y1 over x2 minus x1. So our average rate of change formula is basically our slope formula when we first learned linear equations. Okay? But I am not finding the slope of my actual curve, I am finding the slope of the secant line that goes through my curve. So for average rate of change, you find your starting point, you find your ending point of the region that you're doing the change over, you find your difference of your dependent variables, divide it by the difference of your independent variables. I'm going to do another example. Notes. Let's consider the function f of x is equal to negative 2x squared plus 4x minus 1. And I want to know the average rate of change on the interval from 0 to 1, on the interval from 1 to 2, and on the interval from 2 to 3. So I don't want to stick these numbers in and then keep sticking another number in. I can do that, but I can write a generic equation. So I'm going to do it two ways to show you that there are two methods to do this. So the average rate of change is going to be f of 1 minus f of 0 all over 1 minus 0 for this one. F of 1 means put 1 into my function. 1 squared is 1 times negative 2 is negative 2. 4 times 1 is 4. Negative 2 plus 4 is 2. Minus 1 is 1. So I'm going to end up with 1. Put a 0 into my function. That term goes away. That term goes away, and I get a minus 1. 1 minus 0 is 1. 1 minus a minus 1 is 2. 2 over 1 is 2. So the average rate of change of this function over the interval from 0 to 1 is 2. Now from interval 1 to 2, I can do f of 2 minus f of 1 over 2 minus 1. F of 2 means put a 2 in for x. That would be 2 squared is 4. 4 times negative 2 is negative 8. 4 times 2 is 8. Negative 8 plus 8 is 0. 0 minus 1 is minus 1. Minus f of 1. We found out earlier f of 1 was 1. All over 2 minus 1, which is 1. That gives me negative 2 over 1, which is negative 2. The next average rate of change is between 2 and 3. So I'm going to do f of 3 minus f of 2 all over 3 minus 2. So that gives me f of 3, put a 3 in here. 3 squared is 9 times negative 2 is negative 18. 4 times 3 is 12. Negative 18 plus 12 is negative 6. Minus 1 is negative 7. F of 2 we found out was negative 1. All over 3 minus 2, which is 1. Negative 7 minus a minus 1 is negative 7 plus 1, or negative 6. So the average rate of change of the function on that interval would be negative 6. And what we're seeing is, I'm going to show you, we're going to graph this. We're going to do our quick college algebra review and graph this function, or come up with a quick graph of that function. So first thing I want to do is I want to find the line of symmetry. Line of symmetry is -4 over 2 times -2. So line of symmetry, x equals -b over 2a. So I'm going to put -4 over -4, which is 1. So I know my graph has its vertex at 1. I put a 1 into the function, which I've already done. Putting a 1 into the function, I get 1. And then my shortcut that I taught you is, now if I put the next number to the left, well, actually, let's do it the easy way. Y-intercept is -1. Okay, and when I go over 1 the other direction, I go to -1. The shortcut I was going to talk about says if I go over 1, I'm going to do that many. So that means down 2. And if I go over 2, I'm going to go down 4 times that many. So I'm going to go down -8. So if I go over 1 more, either to -1 or 3, I'm going to be at -8 from there, which would be -7 overall. 3, 4, 5, 6, 7. So here is a rough sketch of the graph of what I'm trying to find the average rate of change of. And what we are actually doing, again, is we are finding the slopes of the secant lines that go through these points. For example, for the first one, if I were to put a straight line through those 2 points, actually, that's the second one. Here's the 3 I did. So this line's right here, its slope would equal 2. This line right here, its slope is equal to -2. And this one right here, we calculated its slope was equal to -6. So by looking at this graphically, we can also ask some other questions and maybe come up with the answers, and we'll check them with the arithmetic. What is the average rate of change between x equals 0 and x equals 2? Well, let's look at what that secant line looks like. That secant line is a horizontal line, and the slope of a horizontal line is 0. But let's check that. I want the average rate of change from 0 to 2. Well, we've calculated both of these numbers. So I want f of 2 minus f of 0 all over 2 minus 0. F of 2 was -1. F of 0 was a -1. All over 2. -1 minus a -1 is -1 plus 1. -1 plus 1 is 0. And 0 over 2 is, in fact, 0. So you should be able to calculate an average rate of change, and I need you to understand that the average rate of change is the slope of the secant line that goes through 2 points on the graph of a function. This last example, if I see I've got a horizontal line there, my slope is going to be 0 for any horizontal line. So the average rate of change, if my secant line is horizontal, is always going to be 0. Look at one more function that we're going to do average rate of change of, and then we'll do another story problem. The next function I want to find the average rate of change is y, or f of x equals 3 halves x plus 5. One, two, three, 4, 5. Then it says to go up 3, 1, 2, 3, and 2 to the right. So that would be a sketch of the graph of the function. And I want to know the average rate of change between 1 and 6. And I'll tell you right now that I don't even want you to write a formula down, because we said that the average rate of change is the slope of the secant line that goes through 2 points on the curve. Well, here is point 1. Here is where x equals 6. So I want the slope of that secant line. Well, if I have a linear equation, the slope of the secant line is the exact same thing as the slope of my linear equation. So this would equal 3/2. Same thing, the interval from -2 to 5 of this equation would be 3/2. The average rate of change from 0 to 0.01 would be 3/2. So anytime that you have a linear equation, I want you to immediately look at the slope from the equation, and that's your answer for an average rate of change. So like I said, that would be my last example for functions, but let's do another story problem, because this is how they're going to come into play for us. Again, you've seen problems like this before in middle school and high school algebra. Say last summer you went down to California and you went to climb Mount Shasta. Mount Shasta is about 14,000 feet. Its summit is about 14,000 feet above sea level. The base of the mountain is about 5,000 feet above sea level. When you started your climb at the base of the mountain, it was 45 degrees Fahrenheit. And when you got to the top of the mountain, the temperature was -15 degrees Fahrenheit. What I want to know is I want to know the average rate of change of the temperature based off of the altitude. So what we're looking for is the average rate of change of temperature. And here's what I'm going to do, is I'm going to use H, stands for my height. T is my temperature. Okay, and one thing I want you to realize is that your temperature is a function of your height. Your temperature is a function of your height. When I write this generic statement, this is my dependent variable, and that is my independent variable. Again, review for you. Just want to make sure we're all talking about the same thing. So I want to find the average rate of change. Well, we said that the average rate of change is equal to the change of the dependent variable over the change in my independent variable. So I'm going to use a subscript S to mean the summit, and I'm going to use a subscript B to mean the base. So my change in temperature is the temperature at the summit minus the temperature at the base over this is supposed to be a delta H here, the height at the summit minus the height at the base. The temperature at the summit was -15 degrees minus the temperature at the base was 45 degrees over the height at the summit, 14,000 feet, minus the height at the base, 5,000 feet. -15 minus 45 is -60 degrees Fahrenheit. over 14,000 minus 5,000 is 9,000 feet. You stick this into your calculator, you are going to get approximately 0.0067 degrees Fahrenheit per foot of elevation. So the average rate of change from where you started to where you stopped is every foot of elevation you went up, the temperature went down 0.0067 degrees Fahrenheit. So that's what we want to talk about for average rate of change. The next video is going to talk about average velocity, which is again an average rate of change thing. I just want to put it in terms of velocity. And then we will be doing instantaneous rates of change. So key points out of this video. Average rate of change is the slope of the secant line that goes through 2 points on your graph of your function. It is the change of your dependent variable over the change of your independent variable on that interval. And it it's basic algebra and arithmetic. There's nothing new here that you haven't learned before.